Hey Jane, so I believe an expert already helped you find the area. Now I'm going to help you find the perimeter. So the perimeter is all these sides added up together. Luckily, the problem already provides the lengths of the bases. So we have base 1 on the top here, 15, and base 2 on the bottom here, which is 21. So two sides down. Now we just have to find the length of this diagonal line on both sides of the trapezoid. And the way we're going to do that is we're going to treat this line like a hypotenuse of a right triangle, okay? So pretty much if we were to draw a line vertically perpendicular to base 2 down here, right? So I'm going to do that right now. And if we did the same on this side, from the edge of base 1 down to base 2, we end up with two right triangles on either side, okay? And I'll just make that really clear by drawing the 90-degree angle. Okay, so we have these right triangles on both sides, and we will find this length here, the hypotenuse, by using the Pythagorean theorem. What is the Pythagorean theorem? Well, voila, is a squared plus b squared equals c squared, and a and b are the legs of the right triangle. So I can write that in here actually. So this is a, this is b, and the diagonal line, the side, is c. So we can only find c by knowing what a and b are. So luckily, a is pretty much provided. The height of the trapezoid is 10, and this leg here is the height of the trapezoid. So we know what a is. It is going to be 10. So let me write that in here. Okay. But how are we going to find this length right here? Right here. B. Okay. And B is on this side as well. Okay. It's a little trickier. Well, if we look at the trapezoid, these lengths, these B lengths, are the parts of base 2 that extend beyond base 1 horizontally. In other words, these lengths make up the difference between base 2 and base 1, the lengths of both of them. And because we can assume that the trapezoid is symmetrical, each length, okay, each B length is going to be the same length, which means that each will be half the difference between base 2 and base 1. So what's the difference between base 2 and 1? Well, we can take the longer length, which is base 2, 21, minus 15, the length of base 1, and then we will get 6. Okay, so that is our difference. And like I said, because each of these leg lengths are the same lengths and add up to 6, this B length is going to be 3 units. And it's going to be the same on this side as well. But now we have A, we have B, and we can plug it into our Pythagorean theorem and find this value, C, okay? So I already wrote this out because I don't have the time. So like, we plug it in, we have 10 squared plus 3 squared here equals C squared, okay? 100 plus 9. So we have 109 equals c squared, and we have to find the square root of both sides. Take the square root of c squared to get c, and take the square root of 109. And then c ends up equaling 10.44, okay? So now we have our answer for c. So this diagonal length is 10.44 units approximately. And the last thing you have to do is add up all the sides. So we have 15 plus 21 plus 10.44 on this side. And remember, it's symmetrical, right? So same thing on this side, 10.44. You add up the lengths of all these 4 sides, and you get your perimeter. So that's pretty much it. You can do that on your own. And yeah, let me know if you have any other questions. And thank you. If you need any tutoring, don't hesitate to reach out. Thanks. Bye.